Okay, good morning to everybody. Today we'll discuss a new part of statistics. Actually, this is a part of measures of dispersion, moments, skewness, and kurtosis. First of all, we will define moments and the relation between two moments, raw moments and corrected moments. Then we'll define skewness and kurtosis respectively. So the definition of moments, actually what is moments? If x1, x2, x3 dot dot, comma x and b and observations of a variate, then r through moments is defined by mu dash r equals to 1 by n summation I equals to 1 to n xi minus a whole to the power r. That means this is the r through moments. Raw moments is denoted by mu dash r. Remember it. And where capital A is the arbitrary value. Okay. Where A is the actually arbitrary value. Remember it. Or it is also called moment about any point. Moment about any points. Or moment about any number. Moment about any number. So now earth corrected moment. Earth now earth corrected moment. Corrected moment. Moment can be defined by mu dash mu r equals to 1 by n summation I equals to 1 to n xi minus x bar. That means it is the mean, arithmetic mean. So earth corrected moment can be defined by or moment about mean, or it is called moment about any point, moment about any arbitrary value is called raw moment, and moment about mean is called corrected moments. Remember this. Where x bar is the arithmetic mean. X bar is arithmetic mean. Remember it. X bar is the arithmetic mean. So the raw moments depends on a, where a is what? Any arbitrary value. Remember it. A is what? Any arbitrary value or origin. Origin. Remember it. Any arbitrary value or origin. A is the any arbitrary value or origin, and this is that means the distance between every mid values from the arbitrary values is denoted by what? Raw moments. And distance from the arithmetic mean is called what? Corrected moment. But it is this moment, this is for ungrouped data. Now for group data, for group data, for group data, this mu r through moments raw moments, what will be? Mu dash r 1 by n summation fi xi minus a whole to the power r. Just we have to multiply the frequency and r corrected moments. Corrected moments mu r what will be 1 by n I equals to 1 to n. Remember it. I equals to 1 to n. So mu r will be 1 by n summation fi xi minus x bar to the power r, I equals to 1 to n. And this is corrected moments and raw moments. This is for group data, remember it. For group data. This is for ungrouped data. If you introduce frequency, then this will be group data and this will be for ungrouped data. Now, what will be the relation between raw moments and corrected moments? Relation between raw moments and corrected moments. Very important result. Relation between raw moments and corrected moments. Now, relation between raw moments and corrected moments. Between raw moments and corrected moments. This is very important for you. Relation between raw moments and corrected moments. We know from corrected, we know from corrected moment, moments, but this is not working well. Corrected moments, mu r equals to what will be? 1 by n summation I equals to 1 to n fi xi minus x bar whole square. Sorry, whole square not. This is r. This is the rth corrected moments. Okay. This can be written by like this. Mu r equals to 1 by n. I equals to 1 to n. Fi we can write like this. Xi minus a minus x bar minus a. Can we write to the power r? Xi minus a minus x bar minus a whole to the power r. Can we write? Can we write? Just corrected moment equals to just we introduced a. This is the arbitrary value, any arbitrary value or origin or assumed mean. So just introducing this, we want to find out the relationship between raw moments and corrected moments. Now remember this from the binomial expansion. We must know there is a binomial expansion a plus x whole to the power n. What is the formula? A to the power n plus nc1 a to the power n minus 1 x to the power 1 plus nc2 a to the power n minus 2 into x to the power 2 plus nc3 a to the power n minus 3 x 3 plus dot dot plus ncr a to the power n minus r into x to the power r. Do you know this formula? Binomial, from binomial theorem. You must know this result. Plus dot dot minus 1 to the power r x to the power r. This is the formula. So just this is a and this is x. Okay. So just writing this formula, or mu r equals to 1 by n summation I equals to 1 to n fi. First what will be? A to the power n. That means this to the power n, xi minus a to the power r. Here the power is r minus nc1. This will be rc1. Okay, because highest power is r. rc1 xi minus a whole to the power r minus 1 into this x bar minus a whole to the power 1 plus rc2 xi minus a whole to the power r minus 2 into x bar minus a whole to the power what? 2 plus this is minus, this plus, then and again minus rc3 xi minus a rc3 xi minus a whole to the power r minus 3 into x bar minus a 3 plus dot dot minus 1 to the power r x bar minus a whole to the power r. Just using this binomial expansion in this. This is a comparing with this. This is a and this is r. Actually, this minus for this minus plus in this way. At last term will be minus 1 to the power r. So r, if r positive negative, then depending on this we can evaluate this expansion. Now considering this is mu r equals to, okay, 1 by n summation I equals to 1 to n fi xi minus a whole to the power r minus rc1 xi minus a r minus 1 into d. Just x bar minus a, writing d plus rc2 xi minus a whole r minus 2 to d square minus rc3 xi minus a whole to the power r minus 3 d cube. Okay, plus dot dot minus 1 to the power r d to the power r, since x bar minus a equals to key what? D. Just taking x bar minus a equals to what? D. Just taking this one, we can find the new result like this. This is the mu r equals to, or mu r equals to 1 by n, just multiplying this I equals to 1 to, this will be 1 to n I equals to 1 to k. So fi xi minus a whole to the power r. Okay, r minus rc1 summation I equals to 1 to k xi minus a whole to the power r minus 1 d plus rc2 summation I equals to 1 to k fi xi minus a whole to the power r minus 2 d square rc3 xi rc3 summation I equals to 1 to k xi minus a whole to the power r minus 3 d cube, and there will be fi in every term fi. Okay, we have to introduce fi plus dot dot minus 1 to the power r d to the power r. So just multiplying this summation to each term and frequency also. So you must know by the definition of, or mu r equals to, by the definition of this we can write what? Earth raw moments. This is the definition of what? Earth raw moments minus, and this is the rc1, this is also r minus 1 raw moments, this is the earth raw moments into what? D plus rc2 r minus 2 raw moments, this is the definition of r d square minus rc3 r minus third raw moments d cube plus dot dot minus 1 to the power r d to the power r, and this is equation number 2, and this is equation number 1, definition of corrected moments. So again we know that first corrected moment equals to 1 by n summation fi xi minus a equals to x bar minus a equals to what? D. First corrected moment d equals to, so we can write here d equals to what? First corrected moments. So now putting r equals to 2, 3, 4, etc. in and mu1 dash equals to d in equation in what? In 2 we get. Class ঢুকো। So just putting r equals to 2, 3, 4, etc. and mu1 dash equals to d in equation 2. Remember it. And you also remember that, and mu0 dash, that means 0th raw moments equals to 1, because power, if power r is 0, then this will be 1. Now if r equals to 2, then mu2, okay, r equals to mu2, and mu2 dash minus rc2 for r equals to 2, that means mu1 dash, and d equals to what? D equals to also mu1 dash, first raw moment, and 2c2, and this is the mu1 dash whole square. D square means what? Mu1 dash whole square, and this is the 0th raw moment, that means 1. So just mu2 dash and mu1 dash whole square, 2c1 means what? 2. mu1 dash what? mu1 dash whole square plus 2c2 means what? 1, and mu1 dash whole square. So minus 2 mu1 dash whole square plus mu1 dash whole square equals to what will be? Minus mu1 dash whole square. So mu2 equals to what? mu2 dash minus mu1 dash whole square. Similarly, if r equals to 3, we get what? Third corrected moment. R equals to 3, third corrected moment what will be? mu 3 dash minus 3c1 mu 2 dash d means what? Mu 1 dash plus 3c2 mu 1 dash whole square. D square means mu 1 dash whole square minus 3c3 mu 1 dash whole cube. D cube means what? Mu 1 dash whole cube, and mu 0 dash means what? Zeroth row moment will be 1. So after calculation we get this 3c1 means what? 3c1. Now 3c1 means what? After this line we can write mu 3 that means third row moments equals to 3c1 means what? 3. Okay, first row moments, second row moments plus 3c2 means what? 3 mu 1 dash whole cube. Okay, mu 1 dash, and minus 3c3 means what? 1 mu 1 dash whole cube. This equals to mu 3 dash minus 3 mu 1 dash mu 2 dash plus 2 mu 1 dash whole cube. Now if r equals to 4, then from 2 mu 4 equals to what will be? Mu 4 dash minus, just putting r equals to 4, 4c1 mu 3 dash mu 1 dash plus 4c2 mu 2 dash mu 1 dash whole square minus 4c3 mu 1 dash mu 1 dash plus 4c4 this is the d cube, remember it, this is the d cube, and mu 1 dash whole to the power 4 into 1. Okay, so mu 4 dash 4 mu 3 dash mu 1 dash plus 4c2 4c4 means what? 6 mu 2 dash mu 1 dash whole square, 4c3 means what? 4 mu 1 dash to the power 4 plus 4c4 means 1 mu 1 dash to the power 4. So at last fourth corrected moments equals to fourth row moments minus mu 3 dash mu 1 dash plus 6 mu 2 dash mu 1 dash whole square minus 3 mu 1 dash whole cube. This is the result. Okay, relation between raw moments and corrected moments. So for r equals to 2, we get second raw moment equals to this one, and for r equals to 3, third raw moments equals to what? This one, and for r equals to 4, fourth raw moment equals to this. We have to remember these three relations, very important relations. Hence second raw moment, second corrected moment equals to what was? Second corrected raw moments minus first raw moment whole square, and third corrected moment equals to what was? For r equals to 3, we got what? This one, mu 3 third raw moments minus first raw moment second raw moments plus 2 into first raw moment whole cube. Okay, and fourth raw moment fourth character moment equals to, we got for r equals to 4, putting equals in equation 2. That means fourth raw moments minus 4 third raw moments into first raw moments plus 6 second raw moments first raw moment whole square minus 3 into first raw moment whole cube. And these relations is very important for you. This is the relation between raw moments and corrected moments. Shepard correction. Now, what is the Shepard correction? Actually, it is generally assumed that the frequency in a group that are concentrated at the midpoints of the class interval, and this is surely an approximation. So, WF Shepard observed that if a frequency distribution is continuous and the frequency tapers up to 0 in both directions of the frequency distribution, then the correction for different moments due to grouping at the midpoints of class interval are done by the following formula. And these three formulas are called Shepard's correction. Mu2 corrected second corrected moment equals to second corrected moment minus c square by 12, where c is the length of the class interval. Remember it. And third corrected moment equals to third corrected moment, but fourth corrected moment is given by what? Fourth corrected moment minus half c square mu2 second corrected moment plus 7 by 240 c to the power 4. Just using this one, we can find the Shepard correction. Now, what will be the formula for Shepard correction? So, Shepard correction formula, what will be? Shepard correction. Shepard correction. Correction formula depending on moments. First corrected moments, second corrected moment corrected by the what? Mu2 minus c square by 12, where c is the what? Class interval. And mu3 equals to third corrected moments like this, and fourth corrected moments can be written as what? Fourth corrected moments minus half class interval whole square me second corrected moments plus 7 by 240 c to the power 4. C equals to what? Class interval, length of the class interval. Okay, length of the what? Class interval. This is Shepard's correction formula. Now, Pearson's beta and gamma coefficients depending on moments. Pearson's beta and gamma coefficient. Beta and gamma coefficients. Carl Pearson defined the following coefficients based on the first 4 character moments we have derived in the earlier of this class. So beta 1 equals to what will be? Beta 1 equals to, this is the formula for Carl Pearson's beta coefficient, mu3 whole square divided by mu2 cube. This is the first beta coefficient, and gamma will be what? Gamma equals to root over beta 1. Okay. Similarly, beta 2 coefficient will be what? Mu4 divided by mu2 whole square, and gamma 2 will be beta 2 minus 3. So this is the formula for what? Beta and gamma coefficients. Now what will be the skewness and kurtosis? Skewness and kurtosis. Skewness formula. Definition of skewness will be, skewness means what actually? This is the lack of symmetry. Skewness is the lack of symmetry. Lack of symmetry. So skewness definition, what will be skewness? Skewness denotes the opposite of symmetry. Opposite of symmetry. Opposite of symmetry. That means it is lack of symmetry. It is lack of symmetry. It is lack of symmetry. So there are two types of skewness. One is positively skewed distribution, another is negatively skewed distribution. Suppose, what is symmetric curve? There are three types of symmetric curve. One is here at this point, mean, median, and mode. Mean, median, and mode equals mean equals to median equals to what? Mode. Then this curve is what? Equals to symmetric curve. Symmetric curve. But when the curve is like this, the curve is like this, or like this. So in this part, we get what? This is the lack of symmetry. That means in this curve, these are not equal. Okay, this is the median is not equal, and this is the mean. This is the mean. Remember it. And this is the mean, and this is the mean. So mean are not equal in these two. There are left tail, left, and this is the right tail. Okay, so left tail is larger. Left tail is larger here. So it is called negatively skewed distribution. Negatively skewed distribution. Okay, and here left tail large. This is why positively skewed distribution. So it is negatively skewed distribution and it is positively skewed distribution. And in this, suppose this is the mean for this curve. This is the mean, and here mean. And this is the, suppose, mode here mean, and suppose median is this. Okay, median is this. So these types of distribution is called negatively skewed distribution. And here suppose this is the median, and this is the median, and suppose this is the mode. Okay, mode. So these types of distribution is called positively skewed, that means right tailed, and this is called negatively because left tailed. But this is symmetric curve because equally distributed by left and right. So that means at this stage this equals to this part. If two part is equal, that means mean equals to median equals to mode, all are equal, then it is called symmetric curve, and this is not anti-symmetric. So skewness equals to what? Skewness denotes the opposite of symmetry. That means which is not symmetric, it is called skewness of that curve. We can measure the skewness. Skewness are two types. One is negatively skewed curve and other is positively skewed curve. Skewness denotes the opposite of symmetry. That means it is a lack of symmetry. So symmetric distribution, a distribution which is not symmetrical, is said to be symmetrical distribution. Okay, in symmetrical distribution, the left tail and right tail are not of equal length. Remember it. This is the left tail. Okay, and this is the smaller is, one is right tail. So it is negatively skewed. Okay, and positively skewed, what? Left tail is less, right tail is longer. Okay, right tail is longer. So in negative distribution, negatively skewed distribution, the left tail is longer than the right tail. Okay, and positively skewed, what will be? In positively skewed distribution, the right tail of the curve will be longer than left. And this is the definition of and always remember that a symmetric curve, my first figure is the symmetric distribution which is plotted in on a graph, will be perfectly bell shaped curve, which is known as normal curve. That means first curve in my figure, it is called symmetric curve. That means equally part left and right. Understand everybody? Now test of skewness. There is no skewness in the distribution if mean equals to median equals to mode. If three are equal, then there is no skewness. Remember it. So there is no skewness in the distribution if third quartile minus median equals to median minus first quartile. You have to remember these properties. There is no skewness if the sum of the frequencies which are less than mode equals to sum of the frequencies which are greater than mode. And number 4 properties, there is no skewness if quartiles are equidistant from the median. Okay, the distribution is negatively skewed if arithmetic mean is less than mode. In second figure, we saw arithmetic mean is less than the mode. Okay, that means mode is the greater, and the curve is not symmetrical curve. It's these three, mean is not equal to median equals to mode. That means if it is not three are equal, then it is not symmetrical or skew symmetric. Okay, so if these three are equal, then it will be normal curve or bell shaped curve or what? Symmetric curve. Remember it. So there are different uses of skewness. It gives the nature of the curve. What will be the nature? Bell shaped or skew symmetric or positively skewed or negatively skewed. That means it gives nature and concentration of observation about the mean. So types of distribution, what? Fairly symmetrical, positively skewed, negatively skewed. There are three types of distribution. We have to remember this one. Now, what is skewness? Okay. Actually, sorry, what is Kartosis now? Kartosis, the degree of peakness the degree of peakness the degree of peakness or flatness of a distribution relative to a normal distribution, to a normal distribution. distribution is called Kartosis. Okay, this is called Kartosis. So Kartosis can be measured by like this. Suppose we can draw a curve like this. We can find these types of graph. Okay, we can find these types of graph. Okay, or we can find these types of graph. Okay, there are three types of graph. Here this is A, suppose A, and this is C. Suppose this is M. Middle one is M, and this is the L, and this is P. Okay, there are three types of curve. So the measures of distributed Kartosis, the measures of Kartosis is given by beta 2. Beta 2 equals to what was? Mu 4 divided by mu 2 whole square, and gamma 2 equals to what? Beta 2 minus 3. Okay, we can measure using this one, which is called the excess of Kartosis, or simply excess. Okay, so if beta 2 equals to 3, remember it, if beta 2 equals to 3, then gamma 2 what will be? Gamma 2 what? 0. Okay, if beta 2 equals to 3, then gamma 2 equals to what will be? 0. Then the curve is normal. Then the curve is normal. That means what? It should be mesokartic. Is mesokartic. Mesokartic. Number 2 definition: if beta 2 greater than 0, beta 2 greater than 3, that means beta 2 greater than 3, then gamma 2 will be what? Gamma 2 will be greater than 0. Then the curve is what will be? Peaked. Okay, then the curve is peaked. P-A-K-E-D. Peaked. Or leptokartic. Or what? Lepto. Or leptokartic. Number 3, if beta 2 less than 3, then gamma 2 will be what? Less than 0. Then the curve is what? Flat. Flat topped or platykartic. Or platykartic. That means there are three types of Kartosis for depending on beta 2 and gamma 2. That means suppose if beta 2 equals to 3, then it is normal. Normal means what? This normal curve. Okay, M. and this is the mesokartic. Okay, and if beta 2 is greater than 3, then peaked, very peaked. Very peaked means what? This one, leptokartic, very peaked. Okay, now if flat, flat means what? This one, this is very flat. This is platykartic. This is called what? Platykartic. This is the curve, different types of kurtosis. So for this one, very highest peaked curve is called leptokartic. Okay, leptokartic, and these are the medium, so it is called what? Mesokartic. And mesokartic is what? Mesokartic beta 2 equals to 3. Okay, beta 2 equals to 3 and gamma 2 equals to 0, then we get mesokartic, this median, and this is very flat curve. So this very flat curve is called platykartic, and this is due to beta 2 less than 3 and gamma 2 less than 3. And for the leptokartic, this is L is missing here, leptokartic, and this is very high peaked curve. So for this high peaked, and beta 2 equals to what? Greater than 3 and gamma 2 greater than 0. So for these three different types of kurtosis, we got this. This is the geometrical interpretation of different kurtosis. Pearson's beta coefficient satisfy the following inequality: beta 2 greater equals to beta 1 plus 1 and beta 2 greater equals to 1. So we must know Karl Pearson's beta coefficient using the properties of Karl Pearson's beta coefficients. We get this inequality. So let let x1 x2 dot dot xn be n observations observations with mean x bar equals to what? Summation xi equals to 0. One by n equals to what will be? 0. Now we know that means x bar equals to what will be? 0. We know we can write an inequality like this: I equals to I 1 to n xi whole square plus bxi plus c whole square is always greater equal to 0, because this is the something square, always greater equal to 0, and sum of all squares will be what? Greater equals to 0, where a, b, c are arbitrary constants. Arbitrary constants. Now we must know a plus b plus c whole square formula. What you must know, we can write, or summation I equals to 1 to n. This will be what? A square xi to the power 4 plus b square xi square plus c square plus twice ab xi whole cube twice bc xi plus twice sc xi whole square greater equal to 0. Okay, just a plus b plus c whole square. Now, or this can be written as summation a square summation I equals to 1 to n xi to the power 4 plus b square summation I equals to 1 to n xi square plus summation c square means what? How many observation? N observation. This is why n times c square plus twice ab summation I equals to 1 to n xi whole cube plus twice bc summation I equals to 1 to n twice sc summation I equals to 1 to n greater equals to 0. Now dividing by n on both sides, dividing by n on both sides, or a square four plus 1 by n I 1 to n xi square plus c square twice ab 1 by n 1 to n plus twice bc and twice sc into 1 by n summation I equals to 1 to n xi square. This greater equals to 0. Dividing by n on both sides. Okay. Since x bar equals to 0, so we get a square. This means what? This means what? Fourth corrected moment plus b square into this will be second corrected moments by the definition plus c square plus twice ab. This is the third corrected moments twice bc into 0. Okay, because summation xi equals to x bar equals to what? 0 plus twice sc into second corrected moment, and this always greater equals to 0 because x bar equals to what? 0. Remember it. And this is the by definition of moments, corrected moments depending on mean. Now put or s equals to 1, a equals to 1 if a equals to 1 and b equals to minus mu3 divided by mu2, c equals to minus mu2, then dividing by mu2 whole square. Okay, just here putting a equals to 1 and b equals to what? Minus mu3 divided by mu2 and c equals to minus mu2, then dividing by mu2 whole square. Okay, so we get here from this line what will be? Mu4 divided by what will be? Mu2 square. Okay, mu4 divided by mu2 square divided by mu2 whole square. Then b equals to what? Minus mu2 by this is the corrected, all corrected moments. So b equals to what will be? Mu3 by mu2. That means what? Mu2, one mu2 will be cancelled. So other will be, we get minus minus plus. So mu2 cube b square into b equals to mu2 cube divided by mu2 whole square. Just dividing by mu2 cube, mu3 whole square. This will be what? Mu3 whole square, mu2 cube. Okay, plus c equals to what? Minus mu2. That means plus mu2 whole square. So mu2 whole square, what will be? Only 1. Okay, plus twice AB, A equals to 1 and B equals to 1, B equals to minus mu2 by mu3 and C equals to this. So we get after multiplication minus 2 mu2 cube minus 2 mu2 cube divided by what will be? Mu2 whole cube. Mu3 whole square divided by mu2 whole cube. Mu2 whole cube twice as C, A equals to 1, C equals to minus mu2 and into mu2. So 2 only plus 2 greater equals to 0. So after this line we get actually this is actually what? Mu4 divided by mu2 whole square according to the Pearson's beta coefficient we get beta 2. This is the beta 2. Okay. This is beta 2. This is minus 2, remember it. So beta 2 and another is mu2 cube by mu3 whole square divided by mu2 cube what? Beta 1. Okay. Plus 1 minus 2 and this is what? Beta 1 whole square. 2 beta 1 minus 1 greater equals to 0. So beta 2 minus beta 1 from this line, beta 2 minus beta 1 minus 1 greater equals to 0. Hence, beta 2 equals to what? Beta 2 plus 1 greater equals to beta 2 plus 1. Okay. Understand everybody? Hello. So we get actually beta 2 greater equal to beta 1 plus 1. That means first inequality. Okay. So in this case, if beta 2 is greater than if beta 2 is 0, that means first Pearson's beta coefficient is 0, then we get immediately beta 2 equals to, if beta 1 equals to 0, then beta 2 greater equals to 1. That means for this proof we have to prove this totally. Okay, we have to start from here, remember it. To prove this result we have to start from here. So very easy inequality, and this is called Pearson's beta coefficient inequality. Okay, thanks to everybody. Today we'll discuss actually about moments, skewness and kurtosis. First of all, we have defined two types of moments. One is raw moments and another is corrected moments. Then we have established the relationship between raw moments and corrected moments. Then we defined skewness. What is skewness? This is the actually lack of symmetry. So there are two types of skewness. Skewness. One is positively skewed and another is negatively skewed. And with geometrical interpretation, I have shown you, and we have defined skewness. And at last, we have defined kurtosis. There are three types of kurtosis. One is very high peaked curve, which is called leptokurtic, and which is where beta equals to beta 2 greater than 3 and gamma 2 greater than 0. And another is mesokurtic. Mesokurtic will be what? Beta 2 equals to 3 and gamma 2 equals to what? 0. Then we get mesokurtic. And then flat, very flat curve, which is called platykurtic. Platykurtic when when beta 2 less than 3 and gamma 2 less than 0. So with geometrical interpretation, we have defined Kartosis. So and at last we have proved a theorem which is related to Carl Pearson's beta coefficient. Okay, so that means there are two inequality. One is beta 2 greater than beta 1 plus 1 greater equal to beta 1 plus 1, and second one is beta 2 greater equal to 1. So we have proved this theorem by using the definition of moments and beta coefficient. So I hope if you do practice more and more, then you can understand better the how what is moments, skewness, and kurtosis. Okay, thanks to everybody, and best wishes for you.